Hi guys, thank you for coming. My name is Mario Fusco, and I work for Red Hat. In particular, I work for on the rules, that is the JBoss rule engine. Okay, but anyway, I'm here to speak about functional programming, of course, but hopefully under a quite different point of view. What's the main purpose of this talk? Honestly, the biggest part of blog posts or articles or even conference talk that I've heard about functional programming, they start explaining you how to do Fibonacci, how to calculate a Fibonacci series, or how to calculate a factorial, and you think, okay, next time I will need a Fibonacci series, I will do that stuff, okay? But the idea is that functional programming is something more than this. I mean, you can use the ideas of functional programming in your day-by-day domain object modeling, okay? Not replacing what you know about the orientation or object-oriented way of doing things, but as a complementary thing, okay? So let's clarify what is for me a functional program or a pure functional program, okay? A pure functional program is, of course, a program that is made only by pure function, meaning that these functions has no side effects, meaning that in theory, your program isn't allowed to do all of this stuff, okay? You are not allowed to reassign a variable, to modify a data structure in place, to set the value of a field of an object, throw an exception, print something to the console, or take the user input, or drawing something on the screen, or writing something on a file, okay? And if you do this 100%, it means that you actually have just one side effect, that is warming up your CPU. That's the only effect, of course, but I'm not saying this. I'm saying that in functional programming, what you do is that of these things that are usually not allowed, the first part are avoidable. You have better way to do that stuff, okay? You can avoid to do that stuff in functional programming, okay? And the other thing, of course, you have to, at some point, take the user input or give to your user any output, okay? And, of course, this is part of your program. You cannot avoid it, but you can defer it, okay? Well, what this means? It means that the core of your program can be made of pure function, and at the extremities of your program, you do a non-pure functional task that is, for example, gathering the input, and at the end, at the other extremity, you do another small non-functional task that is producing the output. But the core of your program can be a pure function. Okay? So this means that functional programming, it is a restriction, but not a restriction on what you can achieve, but how you can achieve it. Okay, so the one of the core principle of the functional programming is that object-oriented makes code more understandable, more maintainable, by encapsulating moving parts, okay? The functional idea is a bit more radical. We don't want to just encapsulate it. We want really to minimize the moving part, hopefully to totally eliminate them, okay? And why we don't want moving part? Why we don't want mutability? For a number of reasons. Because first of all, because immutability, it's easier, it's simpler to design and to use. Think about the new Java 8 date and time API. Somebody using it? Okay, some people. And compare it with the older way of doing data. Okay, with mutability. You say, this is the data, this data is the 8th of June. Okay, now it's no longer June, it's September. That makes no sense even under a domain modeling point of view. Okay? You are creating a new date that is the 8th of September, not taking the 8th of June and make it the 8th of September. Doesn't make any sense. Okay? And of course, it's easier to design immutable object. And the other very important thing in the multi-core processor era is that they are inherently thread safe. Okay, if an object is mutable, there cannot be multiple threads concurring in mutating in states. Okay, so they are inherently thread safe. Okay, so before showing you my example, I want to make a quick premise because I did the similar talks in the past, and the very common question is, okay, do you really expect that tomorrow we start programming in Java in this way? And the answer is not really. I don't do that myself. But the fact is that you have been exposed for years, decades, to the total white of the object-oriented programming, okay? Now, today I'm showing you the total black of the functional programming style, the functional programming way, okay? And I believe that there are at least 50 shades of gray in the middle, okay? So your task as a developer is to find the right shades of gray for the job at hand, okay? Let's start with a very simple but I think interesting example. Tell you a story, a very simple story. We have, and I will tell you this story under two different points of view. I will tell you the object-oriented version point of view, and then I will try to tell you again the same story on a more functional style. Okay, the story is very simple. You have a bird and then you have a cat, and at some point the cat captured the bird, so the cat has a catch, and then you can call the eat method, and at that point the cat is full and there is no longer a catch, of course. Okay, so what you do is creating a new cat, creating a new bird, and call these two methods on the cat object. Very simple. Let's give a look at the functional style story. I still have a bird, but this time I have three types of cats. I have three flavors of cat. Okay, I have a cat that is not full and doesn't have a catch. Okay, then you can call the capture method on it, and the capture method creates a new cat that this time is a cat with a catch, that it has a bird, and you can call it on it, and it will return a full cat. Okay, so this time my story is just made. What can we notice here? Okay, of course the immutability. Okay, but the other interesting thing is that my story now is made by two sub-stories. Okay, and I'm creating the story by composing the two sub-story. Okay, and so the story is now a function that take a cat and a bird as argument and return a full cat. And when I play the story, when I apply the story with a cat and a bird, I'll be returned with a full cat. Okay? That's all. Okay. The other common thing, the other thing to notice that is quite common in functional programming is that I'm making a more expressive use of the type system. As you can see, this version is more verbose because I had to create 3 different class to model a cat. Okay, but in this way, okay. The drawback of this is of course the verbosity, but the advantage of this is that I really don't need to test this stuff. Okay, it compiles and it works. Why? Because I'm not allowed to call the it method on a cat that doesn't have a catch, for instance. Okay, while I could do that on the previous version. Okay, so what's the point here? What's the main difference under a design point of view? The main difference is that when you do object-oriented domain modeling, the accent, the focus is on the knowns. Okay, while when you do functional programming, more often verbs are more important. Okay, so the focus here is on verbs, and these verbs again are the subparts of my story, and by composing them I create my story. Okay, and of course this is a very trivial, a very functional example, but but you can for instance try to translate it in a more real-world example. For instance, you have an API that is an online shop. Okay, so your API is made of these 3 methods. You have a list on item, and you buy them, and it becomes a cart. Then you order the cart, and it becomes an order, and then you ship it. Okay, and the way I designed these 3 methods is because you can concatenate them. Okay, so once again, you have 3 sub-stories, and the full story is the, let's say, the one-click buy function of the Amazon website, if you know it. Okay, because you have the one-click buy that does buy, order, and deliver. That is just a function that is the composition of the 3 sub-functions. Okay, so once again, when you play your story, you just apply the one-click buy to the argument that in this case is the list of items that you want to buy, and you will be returned with a delivery. Okay, so see, this is the very simple, very general idea. Okay, and another thing that I believe is very important is what I think is really the essence of the functional programming. As object-oriented developers, I think we have a big bias. The bias is that we think that on a side we have the data, and on another side, on a totally separated world, we have the algorithms, the methods, the function operating on the data. Okay, what the functional programming is telling you, data and behaviors, data and functions operating on them are exactly the same thing, and you already have these syntaxes in Java. This is a method, I think it has been introduced in Java 5. Okay, and what this method does, it takes data and it takes a function, a behavior. Okay, a specification stating how you can compare 2 items in this list. Okay, so you see I'm treating data and behaviors in the same way, using them as 2 arguments of that are passed to another method. Okay. For instance, I have a list of person and I want to sort them by their ages. Okay. So this is another very important feature of functional programming. I think I will say a further degree of freedom that functional programming gives you. Okay, the ability to mix the data and behaviors. Okay, and I believe that the reason of this, by the way, this is called an higher function. Why? Because I'm passing a function to another function. That's all. And I wrote a book about Java 8, and writing the book and trying to explain the new functional way of doing thing of Java 8 to experienced Java developer, I think I found that, to my surprise, that the idea of high order function is not something so simple as I thought. Okay, and I don't understand why. And I believe the main guilty of this is this book. That, by the way, is just showing you a lots of way of using high order function, but not calling them in that way. Okay, if you think about the command pattern, what is a command? It's a function. Okay, what is the strategy pattern? The strategy is a function. Okay, yes. Sorry, repeat. Why not? Ah, you cannot. Well, you can write the inverse of a function. Why not? And you come up with exactly the same data type, which is called code, which is why I don't agree. I mean, you have to implement the inverse of the command, and you can. You have to have a command and another command undoing the first command. Usually you have it in one output, which is why also creating programming is for me. You have a data structure and you have methods to roll it on, to roll it back, and to show it the history. You can do the same function. You can add a function or remove a function and decide which one you want to apply. Okay, let me recap, sorry. His question is, the main point of the command pattern is that you can add or remove a command. You can execute a command and undo it, okay? So adding and remove a command is the same than adding and remove a function. You have a list of functions, but you are not applying them. In the same way, you have a list of commands, but you are not triggering them. Okay? When you say run, it runs the whole list of commands. When you say apply, it runs the whole composition of functions. But you can pull out a function or pull out a command if you want. Okay? And in the same way, yes, you can do a command, but correct me if I'm wrong. If the command has been already applied, you cannot just undo a command. You have to implement a command that is the dual of the former command. And nothing prevents you to do exactly the same with a function. You can have a function and you can have the dual. Same thing. Okay, anyway, if you are more interested in this topic, I recently published a series of 4 articles on the Voxed website. It's called, I think, Golf Design Pattern in Functional Light. I don't remember the name. But anyway, if you go on the Voxed website, you will see there's a series of 4 articles showing 8 different Gang of 4 design pattern re-implemented in functional style. Okay? Here I wanted to make a very quick example, but again, if you are interested in this topic, I suggest you to give a look at those articles. Anyway, I have a converter here, and what I want to do, I want to define a generic converter to convert unit of measure. So I want to convert miles to kilometers, or I want to convert ons to grams, and so on. And the way you specialize this converter, of course, is giving the appropriate conversion rate for the conversion you want to perform. Okay. And how you use it, you have a list of value that you want to convert, and you pass to this function your list of value and a converter. So you create another list that is the original one where each item has been processed by the converter. Okay, and so you can have a list of figures, of numbers that in this case are miles and are converted to kilometers using the converter, using this converter, and otherwise you can use the other one. Okay, so this is a very simple instance of strategy pattern. Okay, you can do something similar with function. Okay. The way you do this with function is using the carry. What's the carry? The ideas of carry is that you have a function of n argument, n parameters. You fix the value of an argument, and you obtain another function of n minus 1 argument. Okay, that's all. So what I'm doing here is that I have you don't have this feature in the native Java API. I implemented it by extending the by function interface. Okay, as you know, in Java 8 you can have default method, so this is also an interface. It's not a class. And I'm adding these two methods, carry1 and carry2, meaning that in one case I'm fixing the first argument, and in the other case I'm fixing the second one. Okay, so I do exactly the same as the strategy pattern by doing this carry operation. I start from the converter. I just carry fix one argument to the conversion rate from miles to kilometers in this example. And the result is another function that is, once again, my miles to kilometer converter that takes a value and returns a result. Okay, so this is exactly the same thing, or doing the same way. And if you want, you can use this converter inside with the stream API. So you can have a stream of value. This converter is, of course, a function, so you can pass it to the map method, and then you are done with the conversion. Okay. Let's make this a bit harder. Normally conversion, when you convert a value into another, you just have to perform a multiplication. In some cases, this is not enough. For instance, when you convert from Celsius to Fahrenheit, you have to add 32. So what you do is that you create that converter with the carry function, as I showed you before, and then you have another function that adds 32 to the result. Okay, and what you do with this and then is composing this subfunction, these two functions again. And I'm creating a macro function that from the point of view of the user of the function, is just a function from a value in Celsius to a result in Fahrenheit. You don't have to know that this function, as a user of this, of course, you don't have to know that this function is made of the composition of two smaller functions. Okay, but by doing this, I'm improving reusability. Okay, I'm having small building blocks, and since my blocks are as small as possible, it's easier. They are very general, okay, and this means that I can use them in lots of situations, and it's easy for me to reuse them by composing them, okay. I believe that composition does real work in the object-oriented world. It works better with function because functions are small-grained. Okay, so it's easier to compose them. Okay, I want to go quite fast with this part. I'm doing exactly the same thing. I'm adding two more function on that extended by function. This is to compose the by function because you don't have it in plain Java. And I am doing this because I want to do the reverse operation again of the one before. So I have my converter, and before that I have to subtract 32 this time. And once again, it applies what I said before. You have one single function that is a black box for you. If you want, you don't have to know that it's made by the two sub-function, and you can use it the usual way. Okay, so this was the bottom line message this time. Functions are building block. Single responsibility. The smaller they are, the most reusable they are. Okay. Let me show you another example. Okay. I have this salary calculator. I want to calculate a salary starting from a basic, a gross salary, and then I can apply these taxes or bonuses. But I don't want to apply all of them, okay? So what I'm doing is that I want to calculate the net salary starting from the basic one and passing a set of flags saying which tax and which bonus I want to apply to the basic salary, okay? So okay, here I'm not doing any check on the sides of the array for brevity, but you get the point. If the first flag is set, you want to add the allowance. If the second flag is set, you want to add the bonus, and so on. Okay, so the way you use this stuff is this way. And of course, it is not very readable because you have the basic salary, and then you have a bunch of flags. And it's hard to remember the right sequence. It's almost impossible. Okay? So what you normally do in this case, you create a builder, a factory. So you have a builder that set one flag, and maybe you want to be fluent, so it returns this. So you can set again a different flag. Okay? And then the calculator does exactly the same thing. So the essence is the same, but the way you use it this time is that you are building a salary calculator. This time you can read in the code that this salary calculator is applying the bonus and the tax, but it's not applying the two other functions, and then you calculate it, okay? And this is the, of course, the object-oriented story. Let's see if we can do better with the functional version. Of course, here I'm showing only one method, the with allowance, but you have to duplicate this code to do exactly the same thing for each of the flag inside your builder. Okay, let's do something. Let's isolate those function, those tax method that are function in a static class. Okay, why I'm doing this? Because now it's easy. If you think about this, these are just a function from a double to a double. Okay, so what you do is that you can have a list of these functions, and when you say with, you pass. You add a function to this list, and when you calculate, you have a list of functions. You transform this into a stream, you start from the 0, that for function composition, of course, is the identity function. Okay? Start from a 0, and then you compose with and then. Okay? And at this point, you have a function that is the composition of the function you passed here. And then you can just call apply on that function. Okay? The net result is that you don't have to replicate with allowance, with bonus, with tax, and have one method for each of these things. But you can read perfectly. Because you say with, bonus, with, tax, same thing. Okay? But since you have the method reference in Java, the code is as readable, as self-documenting as before, but a lot more less verbose. And the other bonus is that if you have some special tax that you need to apply only in one case, you don't have to implement that function in your builder. You can just, one shot, you need to apply a regional tax. You say with another function, and you are done. You have nothing else to change. Okay, so this is far more flexible. Okay. Okay, this is just a variation of the first of that salary calculator. It does exactly the same thing, but the defect of the flow of the former calculator is that that one was mutable because I was adding the function on the list of function encapsulated inside the calculator. Here, when I say with, I create a new salary calculator by directly composing this function and the one passed here. So when I say calculate, I just say apply, because this function already contains the composition of all other functions. Okay. Okay. Let me quickly talk you about JavaSlang. As I said, you have lots of functional feature and functions class inside the standard API of Java 8. But if you really want to do some functional programming, sometimes they are not enough. You will feel that you are missing something. Okay, so the solution is either doing that extended B function as I did before, or more better, using another library that already encapsulate these features. If you want to go this way, I suggest you to go with JavaSlang. Okay, it has some concepts that are typical of functional programming, like tuples. It has the immutable collection that are quite useful. It has a sort of pattern matching, of course, with the constraint, with the restrictions of the Java syntax, but you can do quite nice stuff. Okay, so give a look at this. Why I'm introducing JavaSlang? Okay, let's take a break and let's take a coffee. Okay, so we go to a coffee shop and buy a coffee. How do you do that? You call the method by coffee, and you pass to that method your credit card, and your credit card is charged, and you get your coffee. Okay? What's the problem of this? The problem is that let's try to reuse this function to create another function that is buy coffees, that allows you to buy a given number of coffees. Okay, you are in the coffee shop with 3 friends, so you want to buy 4 coffees. So you want to use this method and pass a 4 here. Okay, what happens here? I'm using the Java 8 API, the stream API. So I call this buy coffee in a endless stream. I limit this to 4, so I actually call this n times, okay? And each invocation will return a coffee. I collect them into a list and I return them, okay? What's the problem of this? The problem of this is that you have a side effect here, okay? So if you pay a fee every time you use your credit card, you are paying that fee 4 times here. And probably you don't want that, okay? This is the effect of the side effect, the bad effect this time. And the other thing is that it's difficult to test this stuff without a connection to a real credit card that, of course, you don't want, or using a mock. That is a bad practice, in my opinion. Okay, and I told you, if you want to reuse this method, now you are to buy 4 coffees. You are paying 4 fees instead of once. Okay, so let's review again this implementation under a functional point of view. This time I'm not directly charging the credit card, because that will be a side effect, okay? And I don't want that. I want this to be a pure function, okay? So what I'm doing, I'm not only returning the coffee, but I'm also returning the charge. That is the description of how the credit card will be charged, which credit card, and of how much, okay? So how I use it, this time I'm using the JAVASLANG API. So you see the import here, I'm using this JAVASLANG class. So the generate is exactly the same. This time I'm returning with a tuple of coughing and a charge. Okay. So what I want to do is to have the dual, okay? Instead of having a list of tuple, I want a tuple of list. I mean a tuple of list, yes. That are the list of coffee and the list of charge, okay? And then I want to turn this stream of coffee into a list and fold, reduce this list of charge in a single one, okay? And I do this by calling this add method on the charge, okay? So this time the result is a tuple containing your 4 coffee and 1 single charge, okay? And the other advantage is that, okay, you don't have to pay the fee 4 times, but it's easier to test this stuff, okay? You don't have to create a mock and check if the method of the mock has been invoked, because you are not testing the method based on its input and its output. In this case, what's wrong in my opinion? If you want to test this method, you are testing this method not only on its input and its output, but only on a side effect. You want to pass a mock of the credit card and assert that the charge method of that mock has been called. That's sick. That's wrong. Okay? Because you are testing not based on the input and output. You are testing the inner implementation. And instead, in this case, you are returned with a charge. So you can test this making assertion on the charge, on the returned charge. You don't have to pass a mock of the credit card and check how the credit card has been called. Okay, one last thing. One thing that I really don't like is exception. Okay? Exceptions are often abused in Java, especially checked exception. I really hate them. And the reality is that exceptions are just a glorified multi-level goto. That is my definition of an exception. Okay? So what you do to signal an error in functional programming if you don't have if you want to go the functional way and then you decide that you don't want to use exceptions. You use this stuff, okay? When in the signature of a method that you say that throws exception, it means that method may fail, okay? And you can do exactly the same thing in a different way. Instead of throwing an exception and returning a value, you return a try of a value, meaning that value could be there or not. Could be the try could be a success, and in that case everything was okay, and you have the value, or can be a failure. Okay, you have different flavor of this idea that are also in JavaSlang if you want to use them. You have different flavor of this idea. The try is the simple one because you have only the type of the value. The either is the same thing, but this time you have also the type of the exception. The validation, it's even better because you don't have a single exception, but you have a list of exceptions. Because what is the other problem of the exception is that the exception doesn't compose. Okay, you throw an exception and you are done. But if you are validating a bin, you are validating an object, and that object violates 3 criteria. You don't want to throw an exception when the first criteria isn't met. Because in that case, you are telling the user, the age is wrong. Okay, the user fixed the age, then you tell him the credit card number is wrong. And then you fix the credit card because the exception doesn't compose. Okay? Instead, if you can return this stuff, you can return the list of the error in one shot. Okay? So let's do an example. Okay? I told you I wanted to give you real world example. So let's do a bank account this time. You have your account, the balance, and then you can put your money on your bank account. You can credit some money, and you can take money, okay? And of course, when you give money to the bank, everything is always okay. When you try to take money, sometimes something can go wrong, of course. And in this case, maybe because you don't have enough money on your account. And if you don't have enough money in your account, I'll throw this insufficient balance exception. Okay? That is the way I have in object-oriented programming to say, hey, this method can fail. So, okay, what's wrong here? The mutability and the exception. How I use this stuff? Okay, let's say that I want to take 100 euros or pounds from the account A, B, and C. Okay, and I want to gather in this list the accounts that weren't able to pay me this 100 euro. Okay, I typically do this stuff. I do a for loop, a try catch, and when somebody cannot pay, I put the account inside the list. Okay, and okay, this is the for loop, the traditional Java for loop. The problem is that if you try to do this in a nicer way using the stream API and the lambda expression, the result is not so nice. Because exception doesn't play well with lambdas. So you have to put the try catch inside your lambdas. That's very ugly. Okay? And another bad thing is that, okay, that unpaid list is mutable and is outside of the scope of the lambda and is mutated inside the lambda. Okay? So let's try to do a different thing. Let's try to use a try. Sorry. I told you, what is the try? The try is the model of a computation that may fail. Okay, so the computation may fail, or of course can be a success. If it is a success, it wraps the value. If it fails, it fails. It's a failure. You don't know more. You don't know much more about this. It's a failure. Okay. I told you you can use an either if you want to also wrap the type of the failure. You can use a validation if you want to have one more than one failure. Okay. And this is okay. Sorry, I have to say the bad words. This is a monad. Okay. The monad, what it means that is a monad, that this trie can be composed with other trie. So you can apply a function to the trie, and it will transform the inner value if it is a success. Otherwise, nothing will happen. And the same it is with flat map, with the only difference, of course, that you pass a function from A to B to the map method, and a function from A to a trie of B to the flat map method. The usual thing. If you use optional or stream, you have exactly the same thing. So nothing new. Okay. Okay. So what I'm doing here, it's just the same thing. So now it's no longer mutable. Okay, but this is not my main point. My main point, of course, is that here I'm no longer throwing an exception. I'm returning a trie, because that debit method may fail. Okay. So how I achieve the same result as before? I have a set of accounts, and then I transform each account in a tuple containing the account itself and the result of the debit operation. I filter away the one that are not failure. I take the first value of the tuple, that is the account, and I collect it into the list, and these are the set of the account that couldn't pay. Okay, or I can do this in a shorter way, but less readable in my opinion. I mean, since debit already returns a trie, I can check directly its failure on this trie. So this is the predicate, and I can use directly this predicate as the filter condition to collect the account that couldn't pay. Okay, same thing. This is a bit more verbose, but probably more readable. I think so. Okay, let's go a step further. Okay, I don't want this a bank account object. Okay, I want to isolate this the creation of the bank account and the credit and the debit method into pure function. Okay, so I'm making everything static, same implementation, but I'm making everything static, and so since this fail, this cannot fail, this fail, same semantic as before. So when I do open, I'm returning with a trie. When I do credit, I'm calling map because credit is a function from A to B, cannot fail. Same thing for debit. The only difference is that in that case, I have to use flat map instead of map, because debit returns a trie of B, a trie of the bank account, instead of the bank account itself. That's all. Okay? So the idea is decoupling, is that functional programming decouples the state of the object and the behavior that you can apply on the object. This is quite typical in functional programming. Okay, I know that there is this very long debate also in object-oriented programming. Should our bin be anemic or not? Okay, yes, I want an anemic bin in this case and put the function somewhere else. Again, I'm not saying this is the perfect solution for all cases. I'm showing the total black of the functional programming. Use this in your domain if you think it can give you some value. Okay, so let's do one last steps. Okay? What's the problem with what I've done before? Is that I no longer have a state. I no longer have a state, so what if I want to do some, I need a bank connection, for example, to do those operations, okay? What I normally do, I normally use dependency injection to inject the bank connection into my bank account and perform that debit and credit operation. But since everything is static now, I don't have a state anymore. I cannot do this. Okay? How I solve this problem? The easiest way to solve this problem is passing the bank connection to all method, of course. Okay? The implementation is exactly the same, but in this case you have to create a bank connection before and then to repeat it again and again and pass this bank connection around, okay? So I don't like this, of course, because I would like to, okay, my time is up. I will still just 2 minutes, sorry, if you want, or I can stop. I create my bank connection eagerly, and then I have to pass to all methods. So I would like to have this bank connection lazy, and I wouldn't like to repeat bank connection to each invocation. Okay. What I can do, instead of passing the bank connection here, I can return a function that transforms some bank connection to the result, and the same thing for all methods. Okay. So what I'm creating here, when I do open map and flat map and so on, I'm returning this time with a function from a bank connection to the result. Okay, so I'm making everything lazy. I don't have to create this bank connection every time. I still have to, but I have to call this apply to the connection every time. That is equally ugly. I will resolve this later. Okay, so what I've done so far. I started from a pure implementation where the context, the bank connection was injected, and then I did credit, and I mutate S1 to S2 and so forth. Then I transformed everything in static methods, so I have to pass the state around together with the context at each function. And then I transformed the result of this into a function from a context to S1. Okay, then applied this function to the context, I'm returned with S1, and then I'm returning again with a function from a context to S2, I apply again, and so on. Okay, this is what I've done so far. Okay, now let me introduce a second monad, that is the reader monad. The reader monad is just another monad. Yes, I don't want you to focus on the implementation because in Java it's quite embarrassing, I admit this. But the ideas of the reader monad is that it is a monad, it wraps a value. The only difference that the values that it wraps this time is another function. Okay, that's the difference. Why I'm doing this? Because I want to I want to describe the behavior of the function, what the function does, but I don't want to apply it, okay? It's just a wrapper, it's just a description of the function, not its application, not right now, okay? And then I can compose the reader monad with the try reader, okay? I can create another monad this time, okay? And now I'm doing exactly the same thing. Just read the signature. The signature is exactly the same, but when I returned a function to a bank connection to a try account, then I am returning a try reader. And when I returned a function from a bank connection to our account, then I am returning a reader. And what is a reader? Is a function to a bank connection to an account. It's a wrapper of that function. Okay? So what I can do this time is that I can do this stuff. I'm not even replying the bank connection here because it is magically hidden in the implementation of the reader monad. I'm not even mentioning the connection here, but at this point I'm returning with this reader that is a function. I call apply it, passing a connection, and I'm done. Okay, so this is the way, the functional way of dealing with this stuff. Once again, okay, I had to rush a bit in these last slides. Just give a look at my slides and give a look at the code again. But it's not that hard, trust me. Okay, so what I did this time is that I exactly the same version here, but this time I have this red box that is the reader monad that wraps a function, so I can do this stuff. Okay? So let's try to do toward the functional model. It's an iterative process, make everything immutable, confine side effect. Try to avoid exception if you can, and you always can. Try to use your types in a more meaningful way. Use an emic object. Put your domain logic in per function. Okay. Function programming is better composable than the object-oriented version, and most important, try away this. Okay. Throw away this, sorry. And learn some functional pattern. Okay, I'm done. Sorry.